Hey, Kool-aid Krew, what's going on? Hey guys, this is just going to be a quick one. Just want to give you guys a little bit of an update on what's going on with the solar storm. We've entered into a G4 from this blast from the sun the other day, which actually the other day means like a day and a half ago. So this thing is moving fast. It's hitting us hard. Right now we're at G4 level. Well, we might be down to a G3 for a brief moment here, but this is going to be a significant event. So, and I don't think any of us kind of expected anything less. So if I come up here to NOAA, this is what they've been showing us today. Their forecasting is actually pretty much right on it. So I have to give them props for that, 100%. I mean, we really are. This is, I don't think any of us thought this was going to miss. I think the question was how hard it was going to hit when it got here, and if the speed was correct. But the speed seemed to be pretty much like right on where they forecasted. This is the HP. You guys can definitely see here where we have got. Are we? Yeah, we're 5 to 5. Thank you, Alia. Appreciate you, sister. Seriously. All right. So anyway, yeah. So we got this right here. This is we went straight. I mean, from like no storm level to a G3 in 30 minutes. When this thing hit, it hit hard, and we're bouncing up and down between G3 and G4 right now. How do we measure that? We measure that with the KP index, or the HP is the one I just showed you. It's the same indice, but it's just something that they use to gauge how hard or how much geomagnetic activity we're receiving. And as you can see, guys, this is a 3-hour average. These bars are. So boom, boom, right there you go. Now, something that I'd failed to mention before, our radiation storm is pretty much going to go away. And let me explain why. This thing is hitting, like I said, it's hitting hard. When this thing hits, it's moving pretty fast. So when it moves fast, we've got all these protons hanging out in our D region, right? So let me take you down there to that. I forgot to bring that up. Right here. This is going to continually drop off. And what's happening is it's a flushing effect. We get hit, and then the space weather gets dragged right out the back of our magnetotail. Okay? You see how things are starting to kind of lighten up there? If you look this, you can see how the level is starting to drop. Let me do that again. See that right there? Now, it's not going to go completely away right away. But as you guys can tell from the graph up here at the top, it definitely is dropping fairly quickly. Okay? We were at S3 level radiation storm, popping in and out of S3, S2 for, gosh, almost 2 days. So, yeah. S3 is when we really start looking at it, because then it can have biological effects on us. They don't really recommend you fly high latitudes because you get an extra dose of radiation, basically like getting an X-ray. Here is the comet, guys. It almost was daytime visible naked eye. It was point 0.2 away on how bright this thing was going to get, and it barely missed. So this did not become a daytime visible, naked eye visible, I should say, comet. Now, as you can tell, that's the radiation noise. That's from the radiation storm, all that snow-looking stuff. And you can even see here on SOHO where this is starting to lighten up with the radiation. But the geomagnetic activity is what we're talking about today. That's, we can start, we're going to see an uptick in seismic activity. We're going to see an uptick in a whole lot of different things. Believe it or not, guys, house fires, electrical trip outs, all these kinds of things can happen. And they do happen almost every time. People always ask me, well, I never, it didn't affect me. Well, yeah, it kind of did, because everything is being affected, and you just don't know where to go look to see that data. And you have to wait a few days anyway to let that data come in. So it's not going to be an immediate, hey, this is what happened, and nothing's guaranteed to happen anyway. So I will just say that. Now, this is our sun right now. We do have this big coronal hole. That coronal hole is going to be sending space weather our way, also solar wind. So yeah, that's happening. Now I'm going to let you guys see what is actually hitting us right now. This is what's hitting us. This just left the sun, guys, at the turn of the day on the 9th. It only took it less than a day and a half to get here. Okay, so we're talking, I'm not exactly sure on the hour, exactly what's happening with that, exactly the exact time frame, but roughly about a day and a half. That is a fast mover. Okay, that's just what I'll say. It just really truly is. And this was right, I mean, just right in the middle. This thing was not gonna miss us, and I think I've been telling you guys that, and I think most everybody else has too. I would highly encourage you guys to go over and watch Dr. Timothy Scove's video from yesterday. I know everybody was focused on the hurricane, and rightfully so. Okay, this is not going to affect us immediate like that hurricane would down there, and that's one of the reasons why I didn't do anything last night. Okay, everybody's focus was on that, and I thought it needed to stay there, so I did not want to jump out here and take any. Because Adam and Dex over on Marfugal, they did an extended live stream covering that, and I didn't want to take anybody away from that, so I did not go live. But that's why, if you guys are wondering. But that flare right there is and CME that was involved with it. That's exactly what's hitting us now. We also had a couple more off here to the side. There was actually a smaller CME in front of this one. It all got swept up together. Okay, it didn't combine, but it in cannibalistic style. I don't like using that cannibal word because it truly doesn't eat another CME in front of it. Okay, and so let me show you what I'm talking about. So we get two different CMEs, guys. We had two separate ones. One popped off first, and then this one that's hitting us. Okay, so you kind of see, it's hard to see, but it's not, you see this one popping off, but this right here, that's the leading edge of the other one. Sorry guys, that was my alarm. Anyway, so sit down, baby girl, it's fine. That was my dog. My dog's freaking out now because my alarm went off. Anyway, this was the leading edge of a CME right there. And this one's moving about typical speed. Watch the big one behind it catch up to it. And it all gets swept up right now, right at us. So that's happening. And that did increase the amount of density and all that kind of stuff that we talk about. And I know that a lot of you guys are wondering about this. This is Aurora. This is current. So on the night side of the planet right now, they are getting probably the most beautiful Aurora show that they've ever seen in a long time. This is a very significant hit. Now, this is expected to last, guys, okay? And I'm saying that for people like Ilea and everybody else that likes to go out and get the Aurora photography. I will be showing the photography that's sent to me. Okay, I already got some. I'm not going to be able to show you right this second because I have somewhere to be about 4:30, 4:35. So I won't be able to show it to you in this show. There's a possibility I'm going to come back on later on tonight. Not going to give you 100% on that, but I was not going to not come out here and report this to you guys. I need you guys to understand that this is what's happening. So NOAA is actually saying G4, G4, G4 for about 12 hours. Okay, these are 3-hour increments, guys, right here. So you got 3, 6, 9, 12 hours. They're saying consistently G4 for over 12 hours. So that is I've not seen them forecast this like this in a very, very long time. So they had to be extremely confident that that's what was going to happen. Notice that on the 11th, starting now, we're not coming out of G level We're going to stay in geomagnetic storming until about midday on the 12th. Okay? So, yeah. Now, I also want to bring this up too. This can affect ham radio and radio propagation. Guys, that's what a lot of first responders use. So, given the fact that we just had the event down in Florida with Milton, these kinds of things are not good for that. Now, I'm not saying it's it's going to add to the catastrophe or anything like that, but it can hamper the quickness of some of first responders getting to somebody that needs that help. Now, I know that a lot of Floridians took the heat and got the heck out the way, okay? And yeah, they needed to. And I haven't really seen numbers on any kind of, bad stuff like, well, damage and then, not being here anymore. Those kinds of things that I don't like to talk about, and I won't. So, anyway. So this is NASA's version of that same model, okay? So NASA had this thing hitting us. All did. Everything did. Oops. I got to bring that back up for you guys real quick. I want to give you guys an Aurora forecast here, okay? So this is tonight. So, guys, and this is going to stretch down into low latitudes. What that means is it's going to be closer to the equator. This right here, this red line, is just a broad, I guess, forecasting line, okay? The other day when we got to G3, we were getting reports from down here in Texas, down here low into Arizona of Aurora. And this storm is stronger. So it's not a G5 or anything like that. But we actually seen during some G4 storming before, it'll open up cracks in our magnetic field. So we can actually see, we're going to see it down here in low latitude. I'm telling you. We're going to get reports out of Florida. We're going to get reports probably out of Mexico, Southern California. I'm telling you, that's what's going to happen. It's happening every time now. So, and then everybody can have that discussion on why that is. I'm not having that discussion right now. Now, I don't want to forget our friends down in the Southern Hemisphere either. Shout out to my Aussies. Aussie. Anyway, they get an Aurora oval too, guys. They're not left out here either, okay? So you can see how close as night turns in here, it's actually going to be turning to day over there for them. So hopefully they were able to already see some. Chances, most likely there was some Aurora in Australia. This is Africa here, okay? Or is that, nope, that's South America, sorry. This is Africa over here. You definitely could be seeing some right now in South Africa. So, I know I do have a few viewers over there. Shout out to you guys. I wish I could report on things for you guys a little bit better, but it's just not. I don't have the capability to do that. And I appreciate you watching here. And I try to give kind of an overall global thing anyway, but, it's hard to do sometimes. So, anyway, so that's your Aurora forecast. It's supposed to stay, even tomorrow night, guys. See? So given that fact, go around the other way, sweetheart. Go on. Go around the other way. My dog's wanting to crawl across my lap, and I got my laptop on right now. Anyway. Okay. So, let me, I don't want to forget anything here. So we're going to go over here to spaceweather.com real quick. Dr. Tony Phillips. And Dr. Tony Phillips, let's check this out. Oh, I forgot to show you something. He just reminded me. See, that's why I do that. We're going to take a look at the magnetopause models. This is going to show you right here exactly what's happening. This is magnetic pressure. Just a second, sweetheart. Okay? Stop. I need you to stop for a minute, okay, baby girl? Please. So, you're seeing magnetic pressure hit right there. Okay? And as you're seeing that, yeah, my dog just doesn't understand, guys. Obviously, she's a dog. So I try not to get like, oh, some people would be. I don't. I don't do that to my doggy dog. She's like one of my kids. Anyway, so her name is Puka, in case you guys are wondering. And it's actually my daughter's dog. 2 years ago Christmas. But you guys can see how this is our magnetic pressure. See our magneto tail getting stretched out? And this is what I've been talking about, the Aurora substorms. I do think we have a chance of that. If we get these magnetic field lines that break in the front, and if they reconnect back here far enough, in a certain fashion, they will most definitely send it's like an immediate, like 2 jumper cables hit connecting, and you'll get global aurora for about, I don't know, half hour, 45 minutes. Hey, Heather Joy, thank you so much. I appreciate you. I would highlight it, but my live chat highlight thing is turned off right now. I'm not sitting at my desk. I'm out here with my dog because everybody's still at work and school, and I can't be in the other room, the office room. She gets into too much stuff. But thank you. I appreciate you. Thank you so much. It's good to hear from you too. I lose track of a lot of people. You know, I meet so many good people here, and you know, it's just kind of, sometimes it is a little difficult to stay in touch. But guess what? I think I might be able to go face to face tomorrow with one of our good friends, Jammer. We don't live all that far apart, and I think he might be we might be getting together tomorrow for a few minutes. So we're going to see. Hopefully that happens. Anyway, this is speed, okay? Velocity. Obviously, guys, you can see the dark reds. It's moving faster than this dark red, by the way. This doesn't go any higher. Okay, same thing with the density. So why is it white inside back here? Because this is actually inside our magnetic protection. This is our magnetosphere. Our magnetic field is, the conditions inside it are more stable and not as intense. So anything outside our protection is going to be this color dark because it's density, okay? A lot of dense particles, highly charged dense particles surrounding us right now. And that's why you get the magnetic pressure, because it takes all that magnetic field out in front of us, gets compressed closer and closer to our planet, and it adds magnetic pressure. So that's kind of a brief explanation on that. So let's do this real quick. I can show you that model real quick too, and then let's see here. Where is it at? That was the Quake model. Get over and check out Ron on Emergency Management Associates too. I guarantee you he's going to be doing some stuff on this, because he's probably covering some hurricane stuff too. But this is the geoelectric field at the surface. This is not geomagnetism, this is geoelectric. But as you can see, every time we get hit with geomagnetism, it affects our geoelectric. This is space weather's effect on unnatural electrical components. That's what this is, okay? You know, anything that ain't produced by nature. Wall switches, wires, car batteries, all the above. So there you go. This is in an effort to help bridge a gap between earthquake forecasting and space weather. We know that it has a direct effect on seismic activity, but they're trying to you know, get a little bit more knowledge here, collecting all this data to try to better forecast things in advance. You know, if we could get, I mean, just really precise and quicker warnings on earthquakes, we could save so many lives. And that, you know, that's why I really dig this. This is pretty cool. So yeah, I'll say that. One more thing here I want to show you. Okay, this is the Discover graph. I know this is kind of boring to look at, but it's important to know. BZ, guys, anybody looking at this, please go look at all these graphs I'm showing you. Don't trust me, go look at the data for yourself. This red line's called the BZ. This BZ gets highlighted in lavender or purple when it gets to the threshold to where we really couple with the magnetic fields in the CMEs. that threshold number is -6. So when we're -6 or more, we couple to everything and everything gets more intense. If we stay in the positive, we would not be seeing a G4 right now. That's probably right here where it went up. I bet we bumped out for a minute. At least the level lowered. But you can see the density here is fairly high at 16. But the difference here, guys, is our speed was over 800. That's 2 million miles per hour. That's how fast those particles hit us. Okay? So just kind of keep that in mind. So there's your magnetic pressure looking at you. And one more look at the comet here, so you guys get a last look at this thing. It's still going to be on here for a while, guys. It's still in the field of view from SOHO. All right. SOHO, this is LASCO C3 on the SOHO Observatory. Okay. And let's see here. Where's that one at? Right here. This is the same satellite. This is just a zoomed in version. Okay. So that's the comet. It barely missed being a daytime naked eye. You could go out with your binoculars and stuff as long as you had the right protection for your eyes. You would have been able to see this. They actually got some daytime photography of this using a telescope, I think, and some other techniques, but right next to the sun. So for this thing to even be able to be even close to being seen when it's sitting out here next to the sun, we get that forward light scattering. Light from the sun hits the dust and it scatters the light our direction when it's on the same plane. And it crossed our plane yesterday. Okay, so that was as bright as it's going to get. It's not going to get any brighter. And yes, this CME did get hit with this. The CME did hit this comet. I got some stuff I can show you later on that from Stereo A, different satellite. But it did not rip the tail off. There was a chance it could have, but it didn't. So, anyway, I got to get out of here, guys. God bless. Thanks for coming. I might be doing another update later on tonight, guys. God bless. Yahusha saves. And, yeah. As always, you can drink this Kool-Aid.